Welcome to my YouTube channel, and without wasting any time, let's get started. In this session I will be explaining the basic fundamentals of the networks theory. So basically, what is a network? Huh? So basically, what is a network? A network is nothing but the interconnection of elements. Interconnection of elements is known as a network. It may be like this: a resistor, capacitor and an inductor, a battery. The network may be open or may be closed. Whereas what is a circuit? A circuit is nothing but a network which contains at least one closed path. Like this: one resistor and a capacitor and an inductor. It contains one closed path. It is termed as circuit. Okay, now we will be discussing the basic parameters of the networks theory. Basic parameters: first parameter is electrical current. Okay, what is electrical current? The flow of free electrons in a conductor. The flow of free electrons in a conductor is termed as electrical current. It is nothing but, imagine a conductor like this, free electrons. The flow of the free electrons in any direction is termed as an electrical current. It is denoted by the letter I. Mathematically, I is equals to Q upon T or dq upon dt. Units for the current is coulomb, unit for the charge, and second, unit for the time. Coulomb per second is a unit for the current, or the unit for the current can also be ampere. Okay, the second parameter we'll be discussing here is voltage. Voltage, or it is also known as potential difference. Potential difference, it is nothing but the capacity of a charged body to do work. The capacity of a charged body to do work is known as voltage. Okay, it is denoted by the letter V. It is mathematically expressed as V is equal to work done by the charged body Q, or dW upon dQ. Unit for the work is joules and unit for the charge is coulombs. Okay, joules per coulomb, or unit for the voltage is joules per coulomb or volts. Okay, the third parameter we'll be discussing here is power. It is nothing but the rate at which the work is done. The rate at which the work is done. It is denoted by the letter P. P is equal to work done by time, or dW upon dt. Rate in the sense denominator dt with respect to time, it means. Okay, the unit for the power is the unit for the work done is joules. The unit for the time is seconds, joules per second, or unit for the power is watts. Okay, we know that power is equals to dW upon dt. It can also be written as dW upon dq into dq upon dt. I multiplied with dq and dq, divided it with dq. Okay, we also know dW upon dq is what? Our potential difference. Okay, this is our potential difference, and this is our electrical current. It can also be written as V into I. So power is equal to voltage multiplied with current. We can also derive many formulas later. Okay, now the fourth parameter we'll be discussing here is energy. Energy, it is nothing but the capacity to do work is known as energy. Basically, energy is nothing but work done. Okay, energy, it is denoted by the letter E. And is denoted by the letter E, and it is equals to, basically what I said, it is nothing but the work. We know that P is equal to dW upon dt. Basically W is our energy. To get W, we need to integrate P with respect to time. Okay, energy will be equals to integration of P dt over the limits 0 to T. This is our formula. The unit for the energy is, the unit for the power is watt. Watt into the unit for the time, it gets multiplied, right? Hour. Watt into hour. The unit for the energy will be equals to watt into hour. Watt into hour. Okay. Now, Ohm's law. What is Ohm's law? Ohm's law, it states that at constant temperature, the potential difference across a conductor is directly proportional to current flowing through it. Okay, at constant temperature, the potential difference across a conductor is directly proportional to the current flowing through it. Okay, mathematically it can be expressed as V. Potential difference, it is directly proportional to current I. By removing the proportionality constant, we will be replacing it with a constant. V will be equals to I into R. Okay, this is our Ohm's law. And Ohm's law is applicable only to linear and bilateral elements. That's about the Ohm's law, and now we'll be discussing about the classification of the elements. Classification of the elements. Okay, basically elements are being classified into these following categories. Okay, first one is, it can be active and passive elements. Second category is, it may be linear and non-linear elements. Okay, third one is unilateral and bilateral elements. Fourth category is lumped and distributed elements. Okay, so what is active elements? The elements which are capable of delivering energy. The elements which are capable of delivering energy are termed as active elements. Nothing but example for this is voltage source or current source. Okay, passive elements. The elements which are capable of accepting energy, in the sense consuming, which consumes energy, are termed as passive elements. Okay, the elements which are capable of consuming energy are termed as passive elements. Example for the passive elements is our resistor, inductor and capacitor. Okay, now second category, linear elements and non-linear elements. Linear elements. The elements are said to be linear if the VI characteristics is a straight line passing through the origin, and it also satisfies two conditions. It also obeys superposition principle, as well as the principle of homogeneity. Whereas the elements whose VI characteristics does not follows a straight line, or which does not obey these two things, which does not obey the principle of homogeneity and superposition, are termed as non-linear elements. Okay, now let's come to the third category. unilateral. Unilateral, for which the magnitude of the current is not same in both the directions, are termed as unilateral elements. For example, consider this is an element. For this, the magnitude of the current in this direction, let it be 5 amperes. And for the same element, the magnitude of the current in this direction, that is opposite direction, that is 4 amperes. Then such elements are termed as unilateral elements. The magnitude of the current is not same in both the directions, are termed as unilateral elements. Whereas bilateral elements, the elements for which the magnitude of the current is same in both the directions. For example, in this direction, if the value of the current is 5 amperes, then compulsory for the same element in the opposite direction also, the magnitude of the current should be 5 amperes. Then such elements are termed as bilateral elements. Example for the unilateral elements is example for the unilateral elements is diode and transistors. Example for the bilateral elements is resistor, inductor, capacitor. Now let us discuss about the fourth category. Fourth category, lumped and distributed. Lumped and distributed elements. Lumped elements are nothing but a network containing elements which can be electrically separated are termed as lumped elements. For example for the lumped elements is our resistor, inductor and a capacitor. Whereas distributed elements, a network containing the elements which cannot be electrically separated, are termed as distributed elements. Example is transmission length. Transmission length is the example of this distributed elements. Okay, now we'll be discussing about the active and passive elements in little bit detail. Okay, basically the elements are being classified into two types, active and second one is passive. Active elements, again, they are being classified into two groups, independent and dependent. Okay, again these groups, independent group is again classified into two types, ideal elements and practical elements. Okay, it is again classified into two types, ideal current source, ideal voltage source, practical current source and practical voltage source. Whereas the dependent elements are being classified into four categories. These are voltage controlled current source, voltage controlled voltage source, current controlled current source, current controlled voltage source. Okay, these are the four categories of the dependent elements. Whereas coming to the passive elements are nothing but which consume energy. As I said, resistor, inductor and capacitor. We'll be discussing about this in the next video, and we'll be discussing about the active elements in this video. We know about the active elements. Active elements are nothing but the elements which supply energy. Okay, active elements, basically first we need to understand source. What is source? Which supply energy. And if an element is dependent upon any source, which supply energy is termed as a source. And if an element is dependent on the energy, then it is termed as dependent element. And if it is independent on the source, then it is termed as independent element. Okay, depending upon the reliability, independent elements can be, depending upon the reliability of the source, independent elements can be classified into two types, ideal and practical. Ideal in the sense we'll be discussing, this consists of two parts, right? I and V. We'll be discussing about the ideal voltage source. Ideal voltage source. Okay, ideal voltage source which supplies the constant voltage towards the duration of the time. For example, if the voltage is V here, okay, output we are getting here is V out. Imagine V out must be V for any duration of the time. It means like that, which supplies a constant voltage toward the duration of the time. Okay, by seeing the graph you will be understanding. This is time. Whatever the time is, the V out value must be always V. It is constant. Okay. Similarly, ideal current source. Okay, ideal current source, it is nothing but a current source symbol. This is a symbol of the current source. Okay, this is I. Let us assume I, and the output current, that is I out. Just similar to the above case. I out must be constant, that is the value must be I at any time duration, which supplies a constant current toward the duration of the time. It is termed as ideal current source. Okay, now we will be discussing about the practical current source and practical voltage source. Practical voltage source. Practical voltage source. Practical voltage source is nothing but a ideal source with a resistor connected in series. It can be like this: ideal source with a resistor connected in series, and this is the output V out. The energy given by this battery will be consumed by the resistor, so it cannot be able to supply the constant supply throughout the duration of the time. So the graph for this, by seeing the graph you will be able to understand what I am going to tell. This is time and this is V out. Basically we need to get the straight line which is constant, but due to the presence of the resistor, the graph is going to be like this. Okay, the supply concentration decreases with an increase in the time. Okay, practical current source. Practical current source. Practical current source, it is nothing but the ideal current source with a resistor connected in parallel. This is I out. The graph is just similar to the above case. Okay, the graph is plotted between the time versus the current I out, and we need to get a normal, a constant value, but we'll be getting a decreased value because the current will be consumed by this resistor, so we cannot be able to get the constant supply toward the duration of the time. And this is about the practical current source. Now we'll be discussing about the dependent elements. Okay, dependent. Till now we discussed about the independent elements. Now we'll be discussing about the dependent elements. Dependent elements are the elements which depend at least on the current source or the voltage source. Depending upon the dependency, they are being classified into 4 types. As I said, voltage controlled voltage source. Okay, voltage controlled current source, current controlled voltage source, and fourth one is current controlled current source. Basically, the dependent elements, the symbol for the dependency is like this, a diamond symbol, whereas the symbol for the independent elements is a circular symbol. Okay, first one, voltage controlled voltage source, right? We need to, this is a dependent element, voltage source plus and minus. Voltage controlled means some constant into voltage, it signifies as this. This is voltage controlled voltage source. And second category, this is the first category, and second category, voltage controlled current source, right? We need to consider an arrow mark, voltage controlled, so kV. And the third one is current controlled voltage source. It is a voltage source, it is a dependent voltage source, so a diamond shape and plus minus, and it is current controlled, so some constant into some value of the current. Okay, the fourth one, current controlled current source, it is a current source, so we need to consider a current, and it is a current controlled, so some constant into value of the current. So this is about the dependent elements classification, and